Alright, so today we'll be reviewing a related rates problem. And the problem states, a kite 40 meters above the ground moves horizontally at the rate of 3 meters per second. At what rate is the angle between the string and the horizontal decreasing when 50 meters of string has been let out? So as we approach any related rates problem, the best thing to do is to draw a picture to be able to visualize it. So first thing we'll do is draw our kite. Okay, and there's our kite in red. Okay, on this windy day. Alright, and the problem states that this kite moves 40 meters above the ground. Alright, so that height there is 40 meters. Okay, and it wants to know when the angle when 50 meters of string is been let out. Okay, so here you are holding the string. Okay, all right, and from you to the kite you have 50 meters of string. All right, so our goal, okay, is to find this angle here. Okay, we want to find the angle between the string, the 50 meters of string, and the horizontal, okay, which is this part here. Alright, now the next thing after we're drawing the picture is to label what we have, what we want, and what formulas we're going to use to answer the problem at hand. Alright, so first things first, what do we have? We have a rate here. Alright, this 3 meters per second. We're going to label that as dx over dy equals 3 meters per second. What do we want? We want the rate, at what rate is the angle between the string and the horizontal decreasing. Alright, so we want theta, the angle there. And we'll label that as so. Alright, and of course it's what we want, we don't have yet. Okay. And the formulas we will figure out as we move along in our problem. Alright, let me fix my lighting real quick. Alright, we should be right back at it. Alright, so here we go with formulas. So the first things first, 40 meters. We know this kite is moving horizontal, okay? Problem stated, no vertical, so pure horizontal at 40 meters. This is going to stay constant, okay? This is a changing variable, and we want this, okay? So looking at a triangle, okay, we know that the opposite over adjacent is, of course, tangent. All right, so we'll label that as so, tangent theta, and that equals what I just said, the opposite over adjacent, the x. We still don't know what that is yet. Alright, and so what we're going to do, I'm going to rearrange this equation here, make it more simple for us to see. I'm going to bring the x up, okay, and that gives us 40x to the negative 1. Alright, now let's go ahead and we'll take the derivative of this equation here. Alright, we know the derivative of tangent is secant squared theta equals, now we'll use the power rule here. We'll bring the negative 1 down, which gives us a negative 40x, and we'll decrease the power by 1, all right, which gives us negative 2. And now I forgot to mention, since we are working with two variables, we are going to multiply each derivative as so. All right. And that will be labeled dx dt. Alright, so now once again, what do we want? We're looking for d theta over dt, which is what we have here. So I'm going to solve for this. I'm going to move secant squared over. Alright, which gives us 1 over secant squared times 40x to negative 2 times dx over dt. Now, let me give you a hint. If we think about our trig functions, we know that 1 over secant squared can also be written as cosecant squared theta. And then I'm going to move some things around. I'm going to move the x squared back down to the denominator times dx over dt. Okay. Now we need to figure out our missing pieces. Okay. We need to figure out our cosecant squared theta and our dx dt. Now if we look back at our triangle, we see, of course, a triangle and also the Pythagorean theorem. And this can be written as so: 50 squared minus 40 squared, a 3, 4, 5 triangle. Alright, so x squared equals, as we solve this, 2500 minus 1600. Alright, now if we do the math there, that gives us down to 900. Alright, now let's solve for cosecant squared. Alright, now cosecant squared theta equals adjacent over hypotenuse. So we have our x squared over 50 squared, which equals 900 over 2500. As we simplify that, we get 9 over 25 cosecant squared x. So now we have cosecant squared theta, and we also have our x squared. So now let's plug them in. D theta over dt equals cosecant squared 9 over 25 times negative 40, and as we go back to x squared over 900, and now dx dt we can get from our previous, which was given to us, which is just 3. Alright, after math, plug it in our calculators, we get negative 6 over 125. And now remember our units. Okay, we're dealing with theta, so we know we're going to have radians over, as we go back to our rate here, over seconds. Alright, and remember it is decreasing. Now the last thing that we do with every related rates problem is we got to write our final statement. So as we look back to our problem, we can easily state that as the angle is decreasing because it's negative at a rate of, our problem here, our answer, negative 6 over 125 radians per second, when 50 meters of string has been let out. And that is your final statement. So one more time, let's review. First things first, read the problem carefully. Draw out a picture to visualize what you want, what we need to solve. Now, state what we have, what we need, and the formulas we are going to use, and plug it in. And don't forget to write a final statement that should agree with your answer. So this is my tutorial on how to solve a related rates problem. Thank you.